Good morning, mathematicians. Today we're going to be talking about arithmetic series. Go ahead and grab your notes and don't forget to write your objective. Let's dive in. Okay, so we've talked about arithmetic sequences today. So now we're going to talk about the concept of an arithmetic series. Now, an arithmetic series is the sum of an arithmetic sequence. You've kind of already been working with this, but now we're going to talk about a formula that will kind of help you figure it out in a shortcut. So the keywords for a series when you're working with a word problem are words like total, sum, together, things that kind of tell you that we are going to be adding the sequence together. For example, Miss McDougall runs 400 meters and increases the distance each day by 200 meters. How much does she run in total after 7 days? So first, if I create that sequence, the first term being 400, then 600, 800, 1,000, and so on, all the way for all 7 days. If I want to turn that into an arithmetic series, I know that I need to sum that pattern up. So first I create the pattern, and then I want to add that entire pattern up, adding up the terms 1 through 7. And I get a grand total of 7,000 meters. So this is what an arithmetic series is. You just make your arithmetic sequence like we've been doing, find all the terms you need, and then you add them up. Now, that's fine whenever we only have a couple terms to sum up, like 1 through 7. That wasn't too bad. You did some of this in your ACT practice. You added them up, and it's not too bad. But when we start getting to bigger sequences where you need to sum to the 20th term or the 100th term, it's going to become a lot of work. So instead, we have this formula to help you as a shortcut. So right here, we have our first formula you should be writing down, SN, S sub n, which is the S stands for series or sum, is equal to n over 2, parentheses 2u1 plus n minus 1 times d. So we want to use this whenever we know our first term, which is u1, and our common difference d. So when we see, okay, I have a sequence, for example, 6, 10, 14, 18, I know my first term, and I can tell what the common difference is here. We are adding 4, so my common difference is 4. So I'm looking for the sum to 18 terms. Now, again, the long way, I could keep this sequence going until I get to the 8th term and then add all those numbers up. But that sounds like a lot of work. So instead, I'm just going to use the formula and plug in. You can see I kind of color-coded it here for you. So Sn, n is getting replaced with 8. So I have S8 is equal to, and then again, I swapped out the n for 8, 8 over 2, parentheses 2, first term, which is 6, plus 8 again, minus 1 times 4. So you can kind of match up where we have over here. The n is pink, and I put all the places where 8 needs to go. U1 is purple, and I swapped that out for 6. And lastly, the D is 4. And I swapped that out for 4. And you can look at the sequence and see where I got all those numbers from, 6 being the first term, the common difference being 4. So I just took all of my variables, and I swapped them out for their known numbers. And then I put that into my calculator, and I get that the sum of 8 terms is 160. Okay, so that's one formula. I like to refer to this formula as the long formula. There's also a short formula, and that is Sn is equal to n over 2, parentheses u1 plus un. And the un in this case represents the last term. So you want to use this whenever u1, the first term, is given, and un, the last term, are known. For example, let's say that we have this sequence down here, 5, 3, 1, -1, dot, 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 -25. So that tells us that the sequence keeps going. It jumps a bunch of numbers, and then the last number is -25. Now, we know that the 10th term is -25. Find the sum of all 10 numbers. So again, I have my formula. I'm going to plug in. So I get S10. I want the sum of 10 terms is equal to 10 over 2, U1 plus U10. So you see I swapped out the UN for U10. And in this case, U10 is that last term of -25. So I'm going to go ahead and substitute that in. So I get S10 is equal to 10 over 2, parentheses, the first term, 5, plus the last term, -25. And I get the sum of all 10 terms is equal to -100. I refer to this one as a short formula. The short formula is nice to use because you only need that first term and last term in n. But the downside is sometimes you don't always know the last term, so you can only use it whenever you know that last term. Let's look at some examples. So find the sum of this series 2, 5, 8, 11, 14, and 17. How do you do this? Well, we can do it the long way, which is where we just take all those terms and we add them up, and then we'll get 57. Or we can use the formula, and you can see I kind of bolded the two numbers that you'll need right here, the 2 and the 17. And we can plug that into the short formula. S6, and I got that n was 6 because I literally counted how many terms were in here. 1, 2, 3, 4, 5, 6. S6 is equal to 6 over 2, first term plus last term. And then I get the same thing, equals 57. So you can see how doing it the long way and doing it with the formula gives you the same answer. All right, looking at that second practice question, find the sum of 50 plus 48 and a half plus 47 plus 45 and a half plus ... all the way to 80 terms. Now, in this case, I don't have the last term, so I am going to be stuck using that long formula. So there's two things I need for that long formula. I need the first term, which I can see right here is 50, and I need the common difference, which is what is being added, or in this case, subtracted. So I can see that this sequence is going down by, what is it, 1.5? Yeah, 1.5. 50 minus 1.5 is 48.5. Yeah. So I'm going to go ahead and plug that in to our long formula. S80, swapping out n with 80, is equal to 80 over 2. 2, input my first term of 50, plus input 80 again for n minus 1, times 1.5, which is the common difference. Throw that all into my calculator, and I get that the sum of 80 terms is 8,740. Now, this is one of those sequences where I'm definitely grateful for the formula, because writing out all 80 terms and adding them up sounds like it would take forever, and I definitely don't want to do that by hand. All right, practice number 3. Find the sum of the first 25 terms of the arithmetic sequence -4, 1, 6, 11, and so on. So again, I don't have that last term, so I'm going to need to use the long formula. I need the first term, which is -4, and I need the common difference, which in this case, it looks like I'm adding by 5. So I'm going to go ahead and plug that into my formula. Sn becomes S25, n over 2 becomes 25 over 2, 2u1 becomes 2 times -4, plus 25 minus 1, 5. And you can see here that you can write it either way. From the second example, I wrapped the first term, 50, in parentheses. Down here, I just put 2 times -4. It's the same exact thing. It's whatever your preference is. I just like to use parentheses in my calculator. But if you want to use the multiplication symbol, it's the same thing. And I want to plug that into my calculator, and I get S25 is equal to 1,400. All right, for practice number 4. For the 16-term sequence, 60 plus 64 plus 68 plus 72, ... 120, find the sum of the series. So now that I do have that last term and I have that first term, I know that I can use the shorter formula. So I'm going to go ahead and plug into that shorter formula. S16, because there's 16 terms, so n is 16, is equal to 16 over 2, parentheses, and then I input first term plus last term, 60 plus 120. And I get S16 is equal to 1,440. All right. So those were kind of our basic problems. Now we're going to move on to IB problems. We're going to do this together as a class, but if you finish your notes early, I want you to go ahead and try to get started on these. All right, you are ready to go. Good luck.